Hello everyone, this is Mrs. Reed and this is lesson 12.4, the law of cosines. Our objective for today, I can define the law of cosines function and use it to solve for an unknown on a non-right triangle. And we're going to start off with a little recap from the last lesson. To find the area of any triangle given two sides and an included angle, we use the side, angle, side, triangle, area conjecture. Side, angle, side. So the area is A times B times the sine of C divided by 2, where A and B are the side lengths, and C is the included angle. The height of the triangle is not needed since calculating the B times sine of C finds the height of the triangle. To find a missing side or missing angle of any triangle, given two sides and an angle, or given two angles and a side, we can use the law of sines conjecture. So remember, we would have the sine of the angle with the side opposite equal to the sine of a different angle with the side opposite of that. So A, B, and C are the side lengths, and the capital A, B, and C are the opposite angles. And we only need two ratios to solve so that we can just cross multiply. Example 1, using the Pythagorean theorem, find the missing side length of the right triangle. Right triangles are nice. We can use a squared plus b squared equals c squared. All right, please go ahead and do that to find out what x is. This is review. You should be able to do it. If you get stuck, I'll be able to help walk through it in just a moment here. All right, so A and B are the sides, C is the hypotenuse. So we plug it in. X squared plus 12 squared equals 15 squared. So x squared plus 144 equals 225. Subtract 144 on both sides. X squared equals 81. Square root both sides. X equals 9. Unfortunately though, when the triangle is acute or obtuse, the Pythagorean theorem does not work because it is necessary to subtract or add something extra to compensate for the change in angle size. All right, mathematicians found that extra something to be equal to the value of, cross that part off and write what I wrote, please. It's missing a 2. It should be 2 times A times B times cosine of C. When given a triangle with two sides and one included angle, you can calculate the length of the missing side using the law of cosines. The law of cosines is c squared equals a squared plus b squared minus 2 times a times b times the cosine of the angle c. So that's the only angle involved. The rest are sides. All right, we need a picture to go with this. Go ahead and draw yourself a triangle. The height. And then we have our angle C and side B, side A. So then the missing side we'd be finding is little c there. And so A and B are our given sides. Lowercase c is the missing side. And the capital C is the angle opposite of the missing side. So in a moment here, we're going to do some practice problems using the law of cosines. All right, example 2, find the missing side length of this non-right triangle. So we're going to use the law of cosines. I went ahead and wrote that down for us as reference. And so let's go ahead and label our triangle. A and B are the two sides that we know. So this is A and this is B. So then this is the missing side length C, and then this is the angle C. So we go ahead and plug it in. So we get c squared equals a, which is 45, squared plus b, which is 52, squared minus 2 times a, which is 45, b, which is 52, times the cosine of c, which is 36. Next, we're going to simplify 3 parts. This, and this whole thing is one term. So you have to make sure you multiply all of that together. So we go ahead and do that. C squared equals 45 times 45 is 2025. Plus 52 times 52 is 2,704. Minus 2 times 45 times 52 times the cosine of 36 is 3,786. 0.2-ish. So now you go ahead and add and subtract. And we get c squared equals 942.8. To get c by itself, we square root. So c, and since we have to round, is about 31. And this is centimeters. All right, example 3, find the missing angle of this non-right triangle given the 3 side lengths. So this one's going to be a little bit trickier because we're going to have to balance and solve to get this by itself. All right, so I wrote out the law of cosines for us. We need to label the triangle. I'm going to start off with the missing angle C. So this is our missing angle C. So that makes this little c. And then the other 2 sides are just A and B. So we go ahead and we plug in everything that we know. So 250 squared equals A, which is 175, squared plus B, which is 225, squared minus 2 times A, which is 175, times B, which is 225, times the cosine of C, which we don't know. It's X. All right, we need to simplify some things. So 250 squared is 62,500, which equals 175 squared plus 225 squared is 81,250. So I went ahead and added those together just to make it easier. And then we need to do 2 times 175 times 225. We're going to subtract this, which is 78,750. And that's times the cosine of X. Now we just balance and solve. Draw your line down, subtract 81,250 from both sides. So we get negative 18,750, which equals, so that's gone, negative 78,750 times the cosine of x. So we need to get cosine of x by itself, so we're going to divide on both sides by negative 78,750. So when we divide, we get about 0.2381, which equals the cosine of x. And if we want to get x by itself, we need to do the inverse cosine, so you can think of it, if it helps, you can write it on both sides like this. So x equals the inverse cosine of 0.2381. Go ahead and do that in the calculator. And x is about 76 degrees because we were finding the missing angle. So as long as you go slow, take your time, you should be good. Just watch out right here. Students a lot of times will think to add that, but really it's multiplying. So just keep an eye out for that. So this concludes our lesson 12.4.